Imagine walking outside tonight. You look up, expecting to see the familiar glowing shape that has hung above the world for over 4 billion years. Instead, there is nothing. No glowing crescent, no pale light reflecting across the mountains. The sky goes entirely black. At first, people think it's an eclipse. Then they blame the weather. But as the minutes tick by, news spreads across the planet faster than sunrise. Space agencies verify their satellite telemetry again and again. The answer never changes. The moon has vanished. Astronomers point their telescopes upward and freeze. The moon hasn't been covered by debris. It hasn't exploded. It hasn't moved behind the Earth. It has simply ceased to exist, leaving a void where 1 billion tons of rock should be. Millions step out of their homes into a night that feels strangely empty. Without moonlight reflecting onto the surface, natural landscapes become absolute blackness. Forests disappear and mountains become invisible silhouettes. Away from the artificial glow of cities, travelers are suddenly forced to rely on technology just to navigate the path in front of them. This loss is far more significant than a change in scenery. The moon provided the gravitational anchor for Earth's tides and axial stability. Its disappearance marks the beginning of a planetary crisis that will slowly alter the rotation and climate of our world. The moon constantly pulls on Earth's oceans, creating a tidal rhythm that coastal ecosystems rely upon. But when that gravitational link snaps, solar tides take over. They are much weaker, causing massive, predictable surges to collapse into a sluggish, erratic crawl. Coastlines begin behaving differently. Regions that normally see high tides may experience unusually calm, stagnant waters. Entire ecosystems become confused. Crabs emerge at the wrong times, and the rhythmic clock that marine life followed for eons suddenly stops. For many species, moonlight is a survival tool. Newly hatched sea turtles instinctively crawl toward the brightest horizon to find the sea. Without that signal, they wander inland and perish. Many insects depend on the moon for flight direction, and coral reefs synchronize their mass spawning with lunar phases. Nature doesn't panic, it simply becomes confused. But on a global scale, that confusion is deadly. When migration patterns fail and reproduction cycles fall out of sync, the biological foundations of the ocean begin to erode, leaving species unable to adapt to a world without its primary schedule. To understand this deeply tied partnership, we look back 4.5 billion years. A Mars-sized world crashed into the young Earth, blasting molten rock into space. That debris eventually gathered together to become our moon. The moon acts as a counterweight, keeping Earth spinning at a steady tilt, like a balanced top. Without that anchor, Earth's axis would shift and wobble unpredictably. Over millennia, this changing tilt alters the angle of every ray of sunlight striking the surface. This axial instability would force dramatic changes in the environment. Tropical forests that have thrived for millennia could find their climate zones migrating, eventually transforming into regions that can no longer support such dense biodiversity. As the axis shifts, tropical zones may eventually become deserts, while frozen lands begin to warm. These extreme climate transformations would render once productive lands barren, forcing global agriculture to struggle with unpredictable rainfall and shifting seasons. The moon's gravity has also been slowing Earth's rotation for billions of years, stretching our day into a 24-hour cycle. With the moon gone, that gradual breaking process nearly stops, fundamentally changing the rhythm of Earth's days for any species yet to evolve. As climate zones migrate across the planet, civilizations would face impossible decisions about where to move. The loss of the moon would eventually produce a planet with cycles and seasons that humans have never experienced before. Even with these shifts, Earth would not instantly become uninhabitable. The atmosphere and the sun would remain, and life would endure. But survival would be harder on a planet that has lost its oldest stabilizer. Along with the physical changes, we would lose several of humanity's shared astronomical experiences. There would be no more blood moons, as total lunar eclipses would permanently cease to exist. Solar eclipses, among the most spectacular events visible from our planet, would also vanish forever. Without the moon to pass between us and the sun, the sky would never again turn to a midday twilight. Beyond the science, there is the psychological impact. For millions of years, every human ancestor looked up and found the same companion. Removing it makes the universe itself feel unfamiliar, creating a sense of grief that the night sky has become a permanent scar. Future generations would grow up hearing stories about bright nights when entire landscapes glowed silver. To them, the Apollo landings and the eclipses of the past would sound like impossible myths, stories of a world they will never see. The sky above Earth has always looked eternal, but its history reminds us that nothing in the universe lasts forever. Perhaps the greatest lesson is that the most important things are often the ones we stop noticing, simply because they have always been there.